What is your window at?
Okay, here we go. So real quick, I'll just kind of zip through this very quickly. So this is one where you'll actually have the Desmos graphing utility available. So I'm going to pull that one up. On the other, so on one test, you'll have the access to graphing utilities. On the other ones, you'll have access to non-graphing utilities that are still, I can show you some stuff that they do that's still pretty cool, that cuts down on kind of the busy work on a test. Okay, so on the graphing utility, I mean, what would I do if I want to zoom and trace to find this limit? What do I do? I mean, it's pretty straightforward. I'm just going to enter the function. So I got f of x equals, and then just type it just as it's written. So square. And by the way, that's if you type in sqrt and Desmos graphing it, or in the non-graphing, it recognizes that as a square root function. Little shortcut. 2x minus x to the fourth minus, now where do you find a cube root of x? Okay, so, I wonder if you can do CBRT. Oh, you can, that's pretty cool. Okay, if you forget that, this is good to know. So on Desmos, you can show the keyboard, and if you go down to functions, there's a whole, you get these different categories. So I think it's under probably miscellaneous, and there's the nth root. And so it allows you to type whatever index radical you want, okay? Although CBRT, if it happens to be a cube root, CBRT is a good little shortcut too. And then now, remember, this is another common mistake, but you'll catch these because it won't look right. If I want to put the whole thing over something, I have to highlight the whole numerator and then hit the division sign, right? 1 minus x to the 1/4. Okay, so there's my function. All I've got to do now is approach 1 very closely, right? And so I'm just going to blow this thing up for a second here. So if I go out here to, oops, I got to go way up here, don't I? If I go up here close to 1, it's undefined at 1, but what's it trying to be? I get 5.318 on that side, and I get 5.349 on that side. Right, so I could average those two. Does it give us how accurately it wants it? They just want it rounded where they want it. Let me pull up the actual question on the test. To the nearest hundredth. Okay, to the nearest hundredth. So you might be even a little bit limited on Desmos. Now, one trick you can do, I think, on this is you can do, if you make the window smaller surrounding 1. So if I did something like this, like what if I did my graph settings, and I'm going to go from negative 0.9 to positive 0.9 to positive 1.1. I think if I spread the window out, I think that makes it a little bit more precise. Okay, so there it is. And then what I would do is I would just take values very close. Like I would just do f of 0. Something like that, right? And what's it tell me? Really close to 5.33, right? Just use the graph to evaluate a number extremely close to the value you're approaching. In the real world, that's how we take a limit a lot of times, okay?
Real world math.
Okay, so, make sense? Questions? We good on that?
Yeah.
Okay. So what was it, 5.33?
Yeah.
You guys get that the squiggly equal sign means what?
Approximately.
Approximately equal to. Good. Okay, so how about this? So this kind of jump around a little bit. This is Here's an example. You're not going to have access to a graphing utility on this, but you will have access to a non-graphing utility. And so you can check your work on this in that way if you want to. But I want you to know how to do this too. So how would we do this one?
Back to the top.
Back to the top. Good. Okay, so this is going to equal the limit of, and at the very least on this one, gosh, I'll give you access to a computational calculator. I don't know if it'll be necessarily the scientific one, but you'll have access to it, so you'll be able to check, like, you'll be able to do computational stuff, so you don't have to bog yourself down with that. So limit of the top factors into what? X plus 4 and x minus 4, and the bottom is 4 minus x. So you got to be a little bit careful on this one. I don't have cancellation quite yet. What do I have to do?
Take out a negative from the bottom.
Okay, good. So I could, for example, I could multiply the top and the bottom by -1 if I wanted, is one way to think about it, or I could factor out a negative from either the top or the bottom. Either way, right? If I think about this as distributing it or multiplying the top and bottom by negative, you see that that's one way to do this. You might like that way. I could write this as the limit of negative x plus 4 times x minus 4. What happens if I distribute a negative through there? I get an x minus 4. That's my point. It amounts to the same thing, doesn't it?
Yeah.
Right. Either way, I get to cancel the x minus 4s, and now I've got the limit of negative the quantity x plus 4. As x approaches 4, what do I get? Negative 8. There you go. No big deal. Okay. Oops. Next one. Okay, what are we going to do here? Okay, good. So you're tempted to probably say what? Well, maybe you're tempted to say I'm going to use that rationalizing technique on this one, where you multiply top and bottom by the conjugate of the bottom. But don't assume that. I mean, always try what first? Direct substitution. And if I try it here, I think it works fine.
Yeah.
Right? If I try it here, if I plug in 7, I get the answer, whoops. Oh, frozen. I get the answer,
When you're at 18.
49 over, what do I get? Square root of 28 plus 36. 64. So I get 49 over 7 equals 7. Nothing fancy, right? Nothing fancy. Okay. How about this one? Okay, this time, however, if I try direct substitution, what do I get? 0 over 0. Okay, so go. What are you going to do there?
Go.
Think about what you're going to do there. Well, actually, you just tell me. What are you going to do there? What do we do if we have
Set the top equal
complex fractions?
times the top.
Okay, so remember, these are the kinds. If I get an indeterminate form like this, where I get 0 over 0, and I've got a bunch of fractions, I'm going to simplify the top into one big fraction, simplify the bottom into one big fraction, and flip and multiply. So my goal is to turn this into one fraction. And in the process of doing that, I'll be able to cancel stuff. Okay, that's where you don't explicitly factor this, but it works out to be a factoring type problem, like a dividing out type problem, like the first one we did. Okay, so what do I do on top then? What's my common denominator going to be? Good, I'm going to get 6x, so I got to multiply this one by 6 over 6. So I'm going to get, would you agree, I'm going to get 30 over 6x minus, what do I multiply this one by? Okay, so 5x over 6x, all over x minus 6 over 1, I guess. And so on the top, I've got my common denominator. I get 30 minus 5x over 6x. I can flip and multiply that by the bottom now, right? So times 1 over x minus 6, it's getting better. So now what? Okay, I can factor out a 5 on the top, right? So I'm gonna get the limit of 5 times 6 minus x divided by 6x times x minus 6. Okay, and I almost get cancellation.
Take out a -1 in the
Okay, I could factor out a -1 in the top. And that's gonna give me -5 times, good, x minus 6 over 6x times x minus 6. And there was my problem. That's how I got my 0 over 0, wasn't it? So I can cancel those, the offending factors, and now I can just directly substitute. And so if I substitute 6 for x, I just get -5 over 36.
Yeah.
Okay, good. All right, here's another one.
Restaurants this weekend or what?
All right, then.
It's kind of messed up. It's kind of, it's easy actually like they do stuff.
Okay, everybody should be taking a look at that, please.
How many times do we go to your house, Andrew? Maybe I want to see it. I want to see Mrs. Watt here. Show you a girl back. I just want to see that. She makes fun of her, right? Yeah. I'm just saying, like, how many times do we go to your residence? How many times do we go to Patricians in residence? We just go over life, like, there's 8, my house is 0. And then bigger than my house, bro. Yeah, but yours is more open. Dude. We were there from so what's the coffee? Yeah. Everyone's going to Christians in this type of thing. But I don't come here. I mean, I would have to like walk. That ain't it, chief. That's definitely. Wait, that's the that ain't it. Party is I'm about to walk my way. I'm through with that. I'm about to sue you.
From go 12 left, it's 0, but from go right, it's 10, so there's no,
So you're saying after 9?
yeah.
Or indeterminate? But E is.
E is 10.
He's 10.
Yeah.
Have a good time.
Bro, last time we was put spiteball in my driveway until like,
Spitball's fire. Spitball's fire.
but it was so dark.
Yeah. I think I'll get about
I was just, I saw this
Someone like trying to jump over the
Jump
fence.
the fence, yeah.
I hope that you can call another one on this property, because if you do, I will take
Once
it.
we get.
I'm ready. But also, I'm gonna go through my living room. That would be fire. I might take it. I still. I know, no, RV trailer. I think like that utility. First off, I don't have a trailer.
Taste of the body.
Wait, so first off, our RV trailer is 15,000 pounds for parking set. But.
Not for me, it's for A, it's for B and Z.
G would be 2x.
Okay, so what do we, how are we gonna do this?
B would be.
Talk to me.
Substitute X.
Okay, well, okay, so we gotta be,
Direct substitution.
we gotta be real careful about our language and how we approach this. So we wanna know if we're gonna end up doing, by substituting, you probably mean direct evaluation of the limits, good. So we wanna know what's the limit of this function, this piecewise function as x approaches -5 from the left. Okay, so, we're going to, where do we sit, which piece of the function, top, middle, or bottom are we on? In that part of the domain, we're in the top. Well, that's a pretty easy one. What's the limit of 0 as x approaches anything?
0.
0. Okay, so that limit is gonna be, for part A, we get 0. Okay, what about part B? The limit of our function as we approach -5 from the right. Middle. Okay, so part B, we're gonna get the limit of the middle part, the square root of 25 minus x squared, as x approaches -5 from the right. Okay, well, that's gonna give us, if I evaluate directly, it's gonna give us 0, isn't it?
Yeah.
Good. Okay. Okay, so then for part C, what is the limit of the function as x approaches -5?
Here,
Zero. Okay, and because the limit from the left and the limit from the right agree, correct? Okay, so. Because I got zero for both. Okay, what about part D? What if I'm approaching 5 from the left?
Zero.
Okay, that's good, because now we can see if I'm approaching 5 from the left, so for part D, I'm using the middle section. The limit of 25 minus x squared as x approaches 5 from the left is 25 minus 25, which is 0. How about if we're approaching 5 from the right? Good, I'm on the bottom part now, so I'm using 2x for my function. Well, that equals 10. 10 and 0 give me different answers, and so what does that tell me about part F, I guess?
does not exist.
As we approach 5, it doesn't exist.
D-N-E.
Okay, make sense?
Yeah.
Okay, good. All right, how about,
So on the test, if we get that, do we just type in DNE? and all?
it'll be,
It'd be like multiple choice.
yeah, I think it'd be multiple
Oh.
choice, and you'll choose the box that says doesn't exist.
Like, what is it?
Okay, so how about this one?
Thank you. What's up this?
Some more one-sided limit stuff. Okay? So how about this? As we approach -5 from the left, what's the limit of the function? Okay, so what should we do here? There's a really important part of this that you gotta get.
Back to the top.
Good, I gotta factor the top. Okay? Okay, does everybody see why?
Yeah.
Yeah.
Because I know that if I approach 5 from the, -5 from the left, from values like, what would that be, like -4.999 or -5.001? Good, it's gonna be, so like -5 point something, right? -5 point something plus 5 gives me what?
Negative small.
So, okay, so it's 0 minus on the bottom, right? So we know if we get a 0 on the bottom, we gotta know, first of all, does the x plus 5 cancel, right? So we might, if it does, then we might be able to simplify this limit. But even if it doesn't, I've gotta know, is the top gonna be positive or negative, right? And it's very difficult to do that if it's not factored. So for many reasons, we gotta factor the top. All right, so what, if we factor the top, what do we get for f of x? So I get, say it again, x
Minus 5.
x minus 1, good, over x plus 5. Okay, so now, this helps us. So now if I'm approaching -5 from the left, the limit of f of x as x approaches -5 from the left is going to give us, on the bottom, we already established it's a 0 minus, right?
Yeah.
On the top, what are we going to get? As I approach -5, -5 from the left or the right, doesn't matter.
Yeah.
-5 minus 5 is negative times -5 minus 1 is,
Negative.
so now the sign of the top is what?
Positive.
Positive. So I'm getting positive divided by 0 minus, which is what?
Big.
Okay, good. My sign is positive over negative is negative, and because I've got a 0 on the bottom and not the top, it's infinitely big. Right? So we know the correct answer is A, and the answer is negative infinity. Right? So we got to get that thing factored. Okay, what about this guy right here? We're approaching -5 from the right. Well, we can use the same template, can't we? We've
Yeah.
already got it factored. So what's that going to give us then?
Zero.
Yeah, so on the bottom, if we approach -5 from the right, that's like -4.999, right?
Yeah.
So on the bottom, I'm going to get a 0 positive this time. Good. Got a little bit of leftover positive. And on the top, the numbers are the same.
Yeah.
still just approaching -5. And so this time we get positive over 0 plus, so we should get positive infinity.
Correct.
Right. So what's that tell us about the overall limit then? As we approach -5, can we say, it doesn't exist clearly because 0 on the bottom, but does it consistently approach either positive or negative? No, it doesn't. We can't say anything about this one, can we? Can't be more specific. It doesn't approach positive infinity, and it also, I mean, it approaches, we can't say it consistently approaches either one. So we're just kind of stuck with that one being at the end. Okay? The one-sided limits are useful, but the two-sided limit doesn't help us much. What are we at here? 1101. Okay, so there's one other one that I want to give you, and this is kind of, we have to kind of push a little further forward with some stuff we talked about earlier. So this is the only thing today that I would consider to be sort of new learning. Where were we there? Right there. Okay, we're on number 6. We're not going to finish this review today. We'll finish it up. How about if we'll finish the review Wednesday and test Thursday? Okay.
Did you post this so we can work on it?
The practice tests are up. Yeah.
And with the practice test, we can like work on it bit by bit.
Yes.
All right. Because it doesn't say save, it says submit test.
I needed second semester doing Cal State. That's application. They don't need transcripts, they don't need essays, they don't need recommendations. They need absolutely nothing. They barely even know your extracurricular activities.
Where?
At Cal State. Easiest application.
I think on the stage that would be
I was
literally
just
just
the only section I might get.
like you didn't have to write anything.
That was,
Yeah.
but like.
Okay, let's just go through this one together. I'm just going to pull this one up here, and we'll just kind of work through this one together. Can everybody, you guys, can you see that one okay? That's too small. Let me see if I can make it a little bigger. Is that better?
Yeah.
Okay. All right, so this is one where we're trying to find all horizontal and vertical asymptotes. And there's something else, there's some new stuff here, though. We're going to kind of push the frontiers of our understanding of rational functions one small step forward, and this is the last new step for the unit. Okay, so what about this? If we're going to take the limits as we approach plus or minus infinity, this is a pretty easy one. It's a rational function. What's the answer? As x approaches plus or minus infinity by 2. It's going to be 2. And what's our rule for that? If I have rational function where...
They're the same on-
Okay, good. Where we get the same degree polynomials top and bottom, then we know that the answer to the limit is just the ratio of the leading coefficients. Right? Because all we do is look at the dominant terms. And the way to remember that is we only look at the dominant terms.
So you're saying-
Whoops. We only look at the dominant terms. And so the dominant terms, we could write this as the limit of 2x cubed over x cubed, which is clearly just 2, isn't it?
Yeah.
Right? Yes, sir.
So you wouldn't factor that first, then? Because you could factor that.
No, you do not need to. For the horizontal asymptote part, you don't need to, okay? Okay, so we just get 2 for those, don't we? We'll just go through this together. So we get 2, and we get 2. And we check answer, and we're good. Fantastic. All right. Okay, next part. Okay, next part. So, and this is the part I want to talk about. So we want to identify the horizontal asymptotes here, okay? So we got to take a little closer look at this function. I'm going to grab this thing and we'll go look at it. Okay, we'll look at it a little more closely. Okay, you got to pay like extremely close attention for the next 5 minutes because this is something that's pretty subtle, but I want you to get this. So we got to factor the top and the bottom, right?
Yeah.
Okay, what can we factor on the top?
Next.
Okay, so we could write this as x times 2x squared plus 11x plus 12 divided by
You can square it out,
times.
x plus 1.
Okay, so then, do we need to factor this one up here?
Yep.
I mean, let's go ahead and do it, but in hindsight, we'll look and see if we really needed to. Okay, so we can factor that. Show you a little trick for this. You can use, you guys probably know bottoms up, right? You've probably done bottoms up a million times. You know bottoms up?
I remember it
You probably use it or you should probably.
in like 8th grade.
8th grade? Okay.
Well, this,
So I'm gonna open up a new page, and let's just focus on factoring 2x squared plus 11x plus 12.
this is just as a factor.
Okay, I don't like it either. I don't really like it either.
So I don't,
So how would you guys have done this?
Multiply
multiply
times
12 by
2,
2.
and then you just have 2x and 2x.
then you get 2x plus 8.
Plus whatever.
2x plus 3, and then you take it.
Okay, so you guys tell me what you would do, because I wanna maybe give you, there might be a way you can streamline this a little.
So we just, yeah.
So, okay,
12 by
so
2.
you get A times C equals 24,
Yes,
and B equals 11, right?
yes.
Yes.
And so you're looking for magic numbers that do what?
Add to B.
Add to B and multiply to A. Okay, good, good. So what would those numbers be?
8 and
3.
8 and 3, okay. So I'm gonna show you the way I would teach you guys to do this.
Okay.
I wouldn't do this for everybody, but the way I would have you guys do this is I would factor by grouping. Okay, oh, forgot it's Monday. Yeah, I'll show you. We'll pick it up on Wednesday. I'm gone tomorrow. We'll pick this. I'll show you. It's really cool. You're gonna like it. I promise.